Section 8.5 has us working with complex rational expressions. So complex rational expressions sound a lot worse than they actually are if we follow some very specific goals for ourselves as we go through these problems. The main thing we want to note is that the definition of a complex rational expression is a rational expression where the numerator and or the denominator each contain rational expressions. You can also think of this as effectively being, like we have with our two examples that we see here, fractions inside of other fractions. Our first one just has a fraction up top and a fraction down below. Second one has multiple fractions up top, multiple fractions down below, but again, fractions inside of fractions is the easiest way to think on complex rational expressions. It should be noted that when we're going through this section, we're going to be using every single method and strategy and process that we learned from 8.1 through 8.3 to simplify and move through these problems. So review those past notes and go view those other videos as necessary. All of that is required to be able to go through this section. So our main idea with these and our main goal is to simplify these things down. Now, my recommendation to you is in the process of simplifying, we want to make this thing and break it down into smaller, more manageable parts. If you try and work through these problems, as you can see with our two initial face value examples up here, these are not exactly clear and obvious, and I don't think it gives any real hint as to exactly how to solve this thing right from the beginning. So we want to break this thing down. Again, small manageable parts is what we're aiming for. We're going to use 8.1, 8.2, 8.3, 8.4 in small controlled areas, small manageable parts and pieces to go through and get to our overall answer. Now, when we are doing this, I think two things that are absolutely essential in this process, or the suggested process that we're going to have here, is that you keep your work organized and you keep your work labeled. A lot of people try and go through this as quickly as they can, and they don't do all the necessary labeling and organization steps, and that tends to create problems later on in the problem, mainly because, well, we don't know what we just did, we don't know where it goes with the previous problem, we don't know where it goes with what we're doing next, and we just in general lose track of what's going on. So organization is huge with these. And the general warning, again, as I mentioned otherwise, and our goal is to go against this, do not try and simplify these complex rational expressions all at once. A lot of people attempt to do that, and it just doesn't seem to end well. Again, we're going to notice that these have a lot going on with them, and if you try and do all of that everything, all of that a lot that's going on at once, it's just makes these a lot more difficult and a lot more painful than they might actually need to be. So, what we have here is a suggested or a recommended process. Now, you can look up online and see a lot of other processes that people will use, and you're welcome to use those, but this is the one that I recommend using. And again, it's fairly generalized, but it gives you a framework that you can use and apply to every single problem that you're working with. So our first step is we are going to simplify the numerator and denominator individually. We'll go through how to organize this and write this out, but again, simplification, that means we're basically doing our 8.1 through 8.4 methods and processes for just the numerator and then just the denominator. Again, I really want to emphasize, and that's why it's boldface here, doing each of those individually. Could be worth underlining or highlighting that if necessary. Use some form of organization to help with this. Again, we'll go through what that's going to look like. Our goal is to do this in smaller controlled parts, and I think we're going to see in this first step of simplifying, if you can do that, if you can break this down into smaller, more manageable, organized parts, these problems become a lot easier to work with and less overwhelming. So after we've simplified the numerator and simplified the denominator, we're then going to rewrite the equation, or the expression, into a division problem using a division sign. We are essentially going to create a fraction being divided by another fraction. And again, our first and second fraction that we're going to have here are going to be big and gross and terrible looking, but at the end of the day, we have a fraction divided by a fraction. What's nice about this in step 3, where we're told to solve the division problem, is we're going to apply the previously learned property of how we divide fractions. We are going to flip the sign in the middle. So it's, instead of being a division sign, it becomes a multiplication sign. And then we are also going to flip the fraction that comes after the division sign. So the first fraction stays the same. This division sign will become multiplication. And the last fraction will flip. And at that point in time, I now have two fractions multiplying together, effectively making an 8.1 problem. From there, we're going to fully simplify the resulting rational expression, again using our 8.1 methods and processes that we have there. So this is our overall process. I recommend pausing the video here and writing this down for yourself as necessary, because otherwise we're going to jump over and take a look at some examples. So here we have our first example of simplifying and working with complex rational expressions. Now my recommendation to you at the very beginning of these problems, when you are writing them down for yourself, is put parentheses around the numerator and parentheses around the denominator of the overall fraction that we are working with. The reason I recommend doing this is I think it makes it clearer to see this thing is my numerator, this thing is my denominator. It isn't always obvious, as we'll see with some other examples, where one numerator starts, where one denominator ends, and I think this little bit of organization goes a very long way here. So our first step in our process, we're told to simplify the numerator and the denominator individually. Now my recommendation with how to organize this for yourself is, I'll show you here. You're welcome to use this, you're welcome to modify it, it's your call, but something along this line is generally very, very helpful. So I'm going to work with just the numerator here first. So I'm just going to write num for numerator, and I'm going to rewrite the numerator exactly as it was given to me right here. And I'm just going to simplify this thing down and show all of my work for that. I'll then do the denominator all over here. So looking at our first one, our first numerator, I have 1 over x plus x over y. I'm adding two fractions together. This is the 8.3 and 8.4 material. So I need to find the lowest common denominator between these two fractions. And that denominator is going to be xy. So the first fraction is going to need to be modified. It's going to need to be modified and multiplied top and bottom by y. And the second fraction is going to need to be multiplied top and bottom by x. So the denominator of both of those becomes xy. So the first fraction ultimately becomes y over xy. The second one becomes x squared over xy. I then write everything together as a single fraction. Each numerator written inside a set of parentheses all over the denominator. I now look to see, can I combine any like terms in the numerator spot? No, I can't, which is fine. So I can just rewrite my numerator then without parentheses, and that's as much as I can do with the numerator now. So now I need to go through and I need to simplify the denominator. So I'm still in my first step for the overall problem. So work with the denominator right here. And again, I'm writing out my denominator exactly as it was given to me. And now I'm going through and simplifying it. Again, I have two fractions that are being added or subtracted together, so they need to have a common denominator. So let's write that in for ourselves. So LCD for this one is also going to be xy. So I'm going to need to rewrite each of these things and modify them. First fraction is going to get multiplied by y over y. Then the second fraction is going to need to get multiplied by x over x. So my new first fraction is going to become y squared over xy. Make that a clear x there. And then the second fraction is going to be x over xy. I'm then combining everything together as one single fraction. Each numerator, again inside a set of parentheses, all over xy. I then look to see, is this negative sign going to distribute through to anything up top here at all? And all it's going to change is that x is going to become a negative. So not a whole lot. I'm going to get x squared minus y, y squared minus x all over xy. And that's the most that I can do with my denominator of the original fraction. So I'm going to move this off to the side just so I have a little bit more space here. Probably should have done this at the very beginning, but I'll do it now. So now I have my numerator fully simplified, my denominator fully simplified. I can't do anything else to those two things individually. So great, step one is done. Our second step then says to rewrite the equation with a division, or into a division problem using a division sign. So that's going to look like the numerator, our now simplified numerator, being divided by our newly simplified denominator. So again, that's just this guy being plugged in here, this guy plugged in here. So now, to solve this division problem, I'm going to need to change the sign here to multiplication, and I'm going to flip the fraction that comes after the division sign. The fraction in front of the division sign is not going to change at all, so I'm just going to be rewriting that in the line below. And because these two things are multiplying together, I don't actually need to write in multiplication signs at all. I can just have the parentheses next to each other. And now I have two fractions multiplying together. I believe this was our 8.2 material that we covered with this. And now that I have two fractions multiplying together, I can look to see, is there anything I can do with cross cancellation at all? And yes, there is. I have an xy in the denominator and xy in the numerator spot. Those will cancel out to become 1. I'm looking up top and I'm seeing, well, this numerator and this denominator look fairly similar to one another, but I cannot factor anything out of this numerator. I also cannot factor anything out of this denominator, and therefore, because I can't factor anything, I cannot actually cancel anything either. So this is going to have to stay exactly as it is. I multiply the fraction straight across and get x squared plus y over y squared minus x. And that's the best I can do with this. I always look to see, can I factor anything else out or cancel anything else out? But if I can't, then I can't do anything else with this problem. And there we have example 1. Our second example is going to follow basically the exact same process that we did with the first one. Again, I recommend when you are initially writing these things out, putting the numerator and the denominator of the overall fraction inside of a set of parentheses or a set of brackets. For the second example, I'm going to use brackets just to show that we can write it a different way. But if you'd like to use parentheses instead, you're welcome to do that. Just showing a different route that we can take. So my first step, going back to my suggested process, simplify the numerator and the denominator individually. So I'm looking at my numerator here and I'm wondering, can I really simplify anything down? There's no multiplication, there's no addition or subtraction of fractions, so I really can't do anything with the numerator. It's already fully simplified. I then look to the denominator and say, is there anything I could simplify with that? There's no addition or subtraction happening there either, and I can't factor anything in the numerator and the denominator spot. So, okay, I am done. Step 1, both the fractions, or both the numerator and the denominator, have been fully simplified, so we're good to go there. Our second step then says to rewrite the equation into a division problem using a division sign. Okay, so we're just doing a rewriting step. So the numerator divided by the denominator. And now, to solve this division problem, remember, we change the division sign to multiplication, and we flip the fraction that comes after the division sign. First fraction stays the exact same. It's just going to get rewritten again. And I can have the brackets next to one another. That's fine. Again, just like a set of parentheses, if the parentheses are next to each other, the brackets are next to each other, it is implied that there is multiplication that is taking place here. So, I've solved this thing as a division problem. I am now on to step 4. I'm going to fully simplify the resulting new rational expression. So, with two things multiplying together, we can either push it all together as one single fraction, which you are welcome to do, or you can do what I'm going to do here, which is I'm going to simplify and factor these things out as two separate fractions first. For me personally, I lose track of things if I bunch everything together in some instances, and having these brackets in here can help keep things a little bit organized. That's me personally. Just how I go through these. So, if I'm going to try and simplify this down, I need to fully factor everything in the numerator and the denominator of all fractions. So I'm looking at my first fraction, and I can't factor anything out of the numerator, I can't factor anything out of the denominator. So once again, it's just going to get rewritten exactly as it is. That happens fairly frequently with these problems, so if you find, I feel like I'm just rewriting the same thing over and over again for some of these, that's fine. That's just how the problem is. For our second one, second fraction, the numerator is the difference of squares. It's one of our special forms, so we can factor that into b plus 5 and b minus 5. Now that I have everything fully factored in both numerators and both denominators, now I can look to cancel things. I'm noticing that I have a b minus 5 in the numerator and the denominator, those two fractions. I'm also noticing that the numerator of the first fraction has a b in it, and the second denominator has a b squared in that. So both of those can be divided by b, or a b will cancel out both of those. And now, when I rewrite and multiply this thing together and make it one single fraction, I'm going to end up with 3 times b plus 5 divided by a single b left over. And that leftover b is right here. Again, I'm always looking to see, can I factor anything else and then cancel anything else? But I can't. So my final answer for example 2 is going to be 3 times the quantity b plus 5, all divided by b. For example 3, we're going to slightly modify how we set up and go through our steps, while at the same time sticking to them, just for the sake of showing you some different options. Let's take a look at what we're asked to do here. So again, we have the numerator is a single fraction, so not really a whole lot going on there. Again, we're going to put parentheses around this to make sure there's our clear numerator. And then the denominator, we have something subtracting, so we're going to need to do something with that. We're putting parentheses around that to make that our clear denominator. Now looking at the numerator, you might look at this and think, maybe you saw this in some of the other problems or examples that we did, well, I can't do anything to add or subtract or multiply anything together or divide anything together. But maybe I could factor that denominator if nothing else. And if you wanted to, in this early step, you could go ahead and factor the denominator, or fully factor pretty much everything in the numerator of this problem. There's nothing wrong with doing that. It's just not exactly a step that guarantees that you are going to be simplifying what you are starting off with. We're just doing some rewrites. But there's nothing wrong with it, so let's see what that would look like. So if I factor the denominator, I need to find two numbers that multiply to be positive 12 and add together to be negative 7. Well, those two numbers are going to have to be negative 3 and negative 4, so I can factor this thing into x minus 3 and x minus 4. I can't do anything else to simplify from there, but I have fully factored this original numerator out, so when I inevitably am going to try and simplify things down at the very end, I at least have the factoring done. So not a huge amount of work was accomplished with that, but there's nothing wrong with doing that and getting it done ahead of time as well. So you can think of that as an optional step for yourself. Nothing wrong with it, but again, nothing guaranteed is going to come out of it in this part of our overall process. Our denominator, however, we do need to do some stuff with that. We have two of these rational expressions that are subtracting from one another. So let's write those out exactly as they were given to us. And if I am going to subtract these rational expressions, then I need to make sure that I have a lowest common denominator between them. And that lowest common denominator is going to be x minus 3 times x minus 4. So like we've done in the past, if we are going to be modifying them, I need to multiply the first fraction, I should say, top and bottom, numerator and denominator, by the same thing. In this case, it's going to be x minus 4, because that's what's missing from the denominator. And for the second one, we're going to be multiplying top and bottom by x minus 3, because that's what's missing in its denominator. So our new fractions end up becoming 3x minus 12 over x minus 3 times x minus 4, minus, and our second one's going to become 2x minus 6 all over x minus 3, x minus 4. X minus 3 times x minus 4, I should say. I'm now combining all of my numerators together into one single fraction. And again, I recommend that you write each of those numerators inside of a set of parentheses in case we have sign changes showing up, which we're going to have showing up here. So this negative sign here is now going to distribute through to everything in this second set of parentheses. So the signs of both of those are going to need to change before I start combining things together. So I'm going to get 3x minus 12 minus 2x plus 6. I'm leaving the denominator fully factored. And then I'm combining like terms where I can. So my new numerator is going to become, looks like it's just going to be an x minus 6. And then we get x minus 3 times x minus 4 in the denominator still. That's staying the same. So now, looking back to our overall process, I have fully simplified the numerator as best I possibly can. And we didn't actually simplify it, we just did some rewriting with it, which is okay. And the denominator, we actually did fully simplify that thing down. So it's now just one single fraction for the numerator and one single fraction for the denominator. Awesome. Moving on to step 2, we're told to rewrite the equation into a division problem. So let's do that rewrite here. So I have, I'll move it up here a little bit. So I have the numerator, the original numerator, I should say, divided by the original denominator. Again, rewritten, but still the original. And now, solving the division problem, you might be looking ahead and seeing, hey, these both have x minus 3, x minus 4 showing up in them. Something's probably going to happen with that. And if you're looking ahead and thinking on that, great. That is correct. We are going to be doing things with that. If you're not seeing that at this point in time, that's okay. It's totally fine if that's not obvious to you. I would give the recommendation, if you are looking ahead and seeing that, do not abandon the steps of rewriting this division sign and rewriting this second rational expression. A lot of people see those things and they skip steps and they forget to do some steps along the way. Do not do that as you're going through this process. Write all of it out for yourself. So that division problem is going to be rewritten into a multiplication problem. So I'm going to have the first rational expression times, and I'm flipping the second one, just like we did with our previous examples. Oops. There it goes. And now I'd look to see, okay, can I factor and cancel anything else out? Both of these have an x minus 3, so those become 1s. Both have an x minus 4, I can cancel out. Those also become 1s. And my new rational expression in the numerator is just going to be, just going to be 4, and the denominator is going to be x minus 6. Again, we always double, triple, quadruple check, can I factor and cancel anything else out? But if we can't, then we're good to go. So our final answer is going to be 4 over x minus 6, and we're done. Looking at our final example, we're still going to use that exact same process that we've been using up till now, just seeing what's going to give us. So I'm looking at my numerator and the denominator individually. Again, I think it's very handy to put parentheses around this, just to show where numerators and denominators are starting and ending and all of that. So looking at my numerator first, saying, is there anything that's going on that I could simplify, any addition, subtraction, or multiplication that's happening there? And really there isn't. I'm not seeing any other operations like addition, subtraction showing up in there. I just have y over y plus 1. I also can't factor anything like we did in example 3, so I can't do anything at all with the numerator as it's currently written, so I'm going to leave that exactly as it is. However, with my denominator, I have two things adding, I should say. I'm looking all over this page at the wrong things and I'm saying stuff too quickly. So I have two things adding together. Hopefully I can say it correctly. So let's go ahead and write that out and see what we're going to get here. So if I'm going to subtract this thing, once again, I need to make sure I have the lowest common denominator between both of these fractions. Now this 1 that is written out front here is a fraction, and it is implied to be over 1. I'll put that in a different color here just so we can see that. So it is implied to always be over 1. So the lowest common denominator then between 1 and y minus 1 is going to have to be y minus 1. So now, just like we've done with all of our previous problems, I'm going to need to modify this thing. So the first rational expression is going to get multiplied by y minus 1 over y minus 1. The second part, well, it already has that denominator of y minus 1 in there, so it doesn't need to get modified at all, and it's just going to stay exactly as it is. So my new first rational expression is going to be y minus 1 over y minus 1. And then I'm adding that with 1 over my y minus 1. Combining everything together to be one single fraction, I get y minus 1 plus 1 all over y minus 1. And then I combine like terms in my numerator spot. And I'm going to get y up top. y minus 1 left over down below. Okay, so now that we have this, we're going to then rewrite our expression or our equation that we have as a division problem. Our numerator is already fully simplified. Numerator up here, can't do anything else with that. So that's just going to stay as y over y plus 1. It's being divided by our new simplified denominator, so y over y minus 1. And then solving the division problem, we are changing the sign from division to multiplication. We are flipping the fraction that comes directly after the division sign. The first part is staying the same. So I'm getting y over y plus 1 times y minus 1 over y. And now I'm looking to see, can I factor anything out from numerators or denominators? I can't factor anything, any of them there, so everything is fully factored at best it possibly could be. I'm noticing that I have a y in the numerator and the denominator there. They are both monomials, so those can cancel out. And then I'm looking at this y minus 1 and this y plus 1, thinking, well, they're really, really close to one another, but they are not opposites. The y is positive in both instances, and just the 1 has opposite signs. So I can't do anything else with this, and therefore I'm just rewriting everything as one single fraction, and I'm getting my final answer as y minus 1 all over y plus 1. And we're good to go. So bringing everything back together, very end of recap of this. The process I recommend that we use listed here, I would recommend having that written down for yourself. Again, overall with these problems, make sure you're sticking to this goal of trying to break these things down into smaller, more manageable parts, and then bringing those parts together to solve the overall problem. I tend to find that people who do that with these types of problems tend to have a much easier time at getting to the final answer. Now, easier time doesn't mean a shortened time. So you will still find problems that are going to take you 5, 6, 10, maybe 20 lines of work to go through when you do every single step in this process. But that's okay. Some of these problems are going to get gross and terrible and all over the place with what they're going to have you do. But again, if you can do it in small, manageable parts, then you're doing just fine with those. So we had our example problems listed here. Get our answers revealed. Same ones that we went through. And we'll go down and take a look at some group problems or extra practice problems, if you'd like to give those a try. As we've done with the previous ones, I would recommend that you pause the video here if necessary to give these problems a try. So I'm going to scroll down here shortly to the answers so you can compare what you have there. And scrolling down, we have our answers here. Again, you might notice with a fair amount of these that there's a lot of steps involved with them. That's fine. That's just how the problem works itself out. The last thing I will note, looking at group 1's problem we have here, if you wanted to, you could multiply these two factored parts together if you would like to, but it's also not uncommon to see them left fully factored like we have them here. And that'd be perfectly acceptable to do. Make sure you are reading any problems on a test or homework that are specifying if they want something other than that. But otherwise, you should be able to leave your answers in that form and be doing just fine with that. But otherwise, this is our 8.5 material.